All right, today we are really going to get into trigonometry as far as you people are familiar with trigonometry, talking about all the various, there are basically 6 trig functions that you should be aware of. Primarily, there are 3 really important ones that you should be really aware of. But we'll get to all that here in a couple of minutes. Trigonometry, the word itself means tri, means 3. The gono means something to do with angles, and metry means measure. So we're talking about 3 angle measures, and 3 angle measures are in a triangle. So we're going to be dealing with right triangles when we do our study of trigonometry. Now, to get us started here, I want to consider a right triangle that has a 30-degree angle and a 60-degree angle, along with the right angle, okay? For any right triangle with angles of 30, 60, and 90 degrees, the hypotenuse is always twice the length of the shorter side, all right? The hypotenuse is always twice the length of the shorter side. And I picked the 30, 60, 90 triangle for that reason. It's much easier to talk about. No matter what your angle is here, whether it's bigger than 30 or less than 30, the relationship between the opposite side and the hypotenuse will not always be twice. The hypotenuse is only twice when it's a 30 degree, okay? As the angle gets smaller, the 30 degrees gets smaller, the relationship gets smaller than twice, okay? As 30 gets bigger, the relationship gets bigger than twice, okay? So what I want you to see from this is that there's a definitive relationship between the opposite side and the hypotenuse dealing with your angle over there in the corner. It just so happens with 30 degrees, it's twice, okay? And I think I said that backwards. As this side gets bigger, the relationship should get smaller than twice. As this side gets smaller, the relationship should get bigger. But that's not important. Now, there's also a relationship between the longer leg and this shorter side. The longer leg on this side is always √3 times the shorter leg. The hypotenuse is always twice, okay? There will always be a relationship, I'm going to repeat this, between the opposite side and the hypotenuse. It is not always twice, but no matter what your angle is, there's a relationship that holds true no matter what the size of the triangle. In other words, I can make this triangle as big or as small as I want. Okay, I can have it so small it would take a microscope to see it. But as long as that angle is 30 in the corner, the hypotenuse will always be twice the length. Okay, I can make the triangle as big as I want. And as long as there's a 30 in that corner, we know that the hypotenuse is always twice the opposite side, okay? The beauty of that is, it doesn't matter how big or small, the ratio will always stay the same. We can give that a name. We're going to call that the sine of 30 degrees. The sine of 30 will always be the opposite side to the hypotenuse. So here, if this is 30, the opposite side over the hypotenuse is the sine, okay? And that's where the trig functions come from, okay? That's where the trig functions come from. The 3 major trig functions. Sine of theta, you write it, you can skip the letter E. It's still pronounced sine, not sin. There's enough of that around. It's still pronounced sine, okay? Sine of theta is the opposite side over the hypotenuse, okay? No matter what the angle is, as long as you have a right triangle. The cosine of theta, or abbreviated COS, still pronounced cosine, is the adjacent side over the hypotenuse, okay? Tangent of theta, abbreviated to TAN, tangent of theta is the opposite side over the adjacent. Now, some people get mixed up on adjacent, okay? Adjacent simply means beside, all right? So if this is your angle, you might say, well, how do I know that's the adjacent side? Isn't that beside also? Well, yeah, it is, but that darn it's the hypotenuse. The hypotenuse can only be one thing. we're talking the adjacent leg or the opposite leg, okay? So the adjacent side is always on a leg. It's never on the hypotenuse. Now, as you may all have learned back in high school, okay, SOHCAHTOA is a great, easy way to remember the trig functions. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. See it? Tangent, opposite over adjacent. Absolutely the easiest way to remember your trig functions, okay? The important thing is, can you do problems with them? Now, that's only 3 trig functions, okay? There are 3 other ones, but they're so easy. The cotangent of an angle is simply the reciprocal of tangent. So if you can do the first 3, you can do the remaining 3 because they're just reciprocals. Secant is 1 over cosine, cosecant is 1 over sine. And they go in reverse order. As you come down the list, sine, cosine, tangent, then when you get to cotangent, you're in a sense going back up. So you come down, sine, cosine, tangent, then cotangent is 1 over tangent, secant is 1 over cosine, and cosecant is 1 over sine, and you get back to where you started from, okay? We will do very little of this, but we will do some of it, all right? The 3 most important ones, obviously, are sine, cosine, and tangent, okay? All right, so let's start talking about some problems here. The sine of angle A, the sine is opposite over hypotenuse, and you're going to have to remember SOHCAHTOA so you can do these problems. Sine is opposite over hypotenuse. Sine of angle A is 3 over 5. Okay? Tangent of angle B. Tangent is opposite over adjacent. Okay? Opposite over adjacent. So for angle B, the opposite side is 4 over the adjacent is 3. It's not 5. So tangent of B is 4 over 3. Secant. We know secant is the reciprocal of cosine. We just talked about that. So cosine of A is adjacent over hypotenuse. So the cosine of A is 4 over 5. So the secant is 5 over 4. Okay? The cosine of angle B. Cosine, adjacent over hypotenuse. So angle B is adjacent, 3 over 5. Everybody with me so far? Tangent of angle A. Tangent of angle A is opposite over adjacent. Opposite of A is 3 over 4. Okay? Cosecant of angle A. Cosecant is the reciprocal of sine. All right, so let's do the sine of A. Sine, opposite over hypotenuse, is 3 over 5. So the cosecant is 5 over 3. Okay? Sine of angle B. Sine of angle B is opposite side, opposite over hypotenuse, 4 over 5. I know I'm going through these quickly. Once you get this down, you'll be able to do them just as fast. Cosine of angle A. Cosine, adjacent over hypotenuse, 4 over 5. Cotangent of A is the reciprocal of tangent. Tangent is opposite over adjacent, so the cotangent of A, opposite over adjacent, tangent is 3 over 4. So cotangent is 4 over 3. Yeah? Oh, yes. Once you get that memorized, you will have no trouble whatsoever. Find the 3 trig functions of the smallest angle. Here is your smallest angle. I can get the sine. Sine is opposite over hypotenuse, 9 over 14. Yeah? Cosine. Yikes. To do the cosine of the smallest angle, I need this side. So I'm going to have to do Pythagoras. Okay? Pythagorean theorem, 14 squared is 196, I think, minus 81 equals 115. So I need the square root of 115 is 10.72. So this side is 10.72. So the cosine of that smallest angle would be 10.72 over 14, okay? I'm just double checking my work here. Yeah, I think that's right. All right, how about the tangent of that smallest angle? The tangent of the smallest angle is opposite over adjacent, would be 9 over the 10.72. I would divide these out. Don't ever let a decimal as a fraction. So this one divide out, and 9 divided by 10.72. Divide it out and get a decimal. Okay, special right triangles. There are 2 of them. The only thing that's really special about these, if you learn these sides, okay, if you learn these sides, then they are remarkably easy to do problems, okay? For instance, the sine of 30, all right? You can punch in the sine of 30 on a calculator. I will talk more about that in a second. You can punch it in, but in a 30, 60, 90 triangles, from what we just said when we started this discussion today, is that the opposite side is always half of the hypotenuse. So we know the opposite side is 1, the hypotenuse is 2, and to go from the little leg to the longer leg, it's times √3. So the sides on a 30, 60, 90 triangle, the small side is 1, the hypotenuse is 2, the longer leg is √3, okay? So the sine of 30 is 1/2, 1 over 2, opposite over hypotenuse. Cosine of pi over 6. Pi over 6 is radians, okay? Pi over 6 is radians, so let's change it to degrees. Pi over 6, we want to get degrees, we want to get rid of the pi's. They go away, 6 into 180 is 30. So pi over 6 is really 30. I want the cosine of 30. Cosine is adjacent over hypotenuse, √3 over 2. Okay, I think it's like 0.866 as a decimal. Tangent of pi over 3. How about pi over 3? Once again, change it to degrees, and I get 3 into 180 is 60. So I want the tangent of 60 degrees. Tangent is opposite over adjacent. So the opposite side of 60 is √3 over the adjacent 1. Tangent of pi over 3 is the same as tangent of 60, is √3 over 1, or just √3. Okay? You're going to be doing this a lot. I talked about this the last time we had class. When you don't like radians, change them to degrees. Okay? And that's the way to do it. Okay, here's the other special right triangle. If you have a right triangle with a 45, 45, 2 angles are the same, these 2 sides are the same, and you can do Pythagorean theorem and get √2 for the hypotenuse. 1, 1, √2 are the sides of a 45, 45, 90, and on the 30, 60, 90 we just talked about on the previous slide was 1 on the little side, 2 on the hypotenuse, and √3 on the longer leg. So how about the sine of 45? The sine of 45 is opposite over hypotenuse, 1 over √2, okay? I do not get upset with a root on the bottom. You may remember from high school days, you were told to get rid of the roots on the bottom. That doesn't bother me, okay? You can let a root on the bottom. Cosine of pi over 4, here we go again. Pi over 4 is radians. You want to get rid of that. 180 over pi, kill them. 4 into 180 is 45. I want the cosine of 45. Cosine adjacent over hypotenuse. If I use this 45, adjacent 1 over √2, which is precisely what we got for the sine. Remember, sine of 45 is also 1 over √2. How about the tangent of pi over 4, which is the tangent of 45? Tangent of 45 is opposite over adjacent. Opposite over adjacent, 1 over 1 for the tangent. Okay? Is this bringing back on memories of high school? Find the missing sides and angles. Okay? let's first find the missing angle. This is really easy. 90 and 70 is 160, and you know there's 180 in a triangle, so that has to be 20, okay? All right, so now what I want to do is find the missing sides, okay? So if I know this is 4, I could do, let's think of trig function here that deals with the opposite and hypotenuse. Opposite and hypotenuse is sine, so let's set up the sine of 70. Sine of 70 degrees is the opposite side, x, over the hypotenuse 4. Take your calculator. First, make sure your calculator is in degrees. You probably have a mode button or a DRG button. Okay, I have a DRG. You may have a mode, M-O-D-E. You may want to push that and see what your calculator is working in. Okay, you want to make sure it's in degrees. So I am definitely in degrees. Okay, so I'm ready to go here. The sine of 70. So I simply put sine of 70 and I get 0.9397. 0.9397 is x over 4. Cross multiply, simply take it times 4, and I get that that missing side that has a question mark on it is 3.76. Okay? So now you've got 4 here and 3.76 here. There's 2 ways you can go about finding this side. You can either do cosine of 70. Is this over 4? Okay, or you could do Pythagorean theorem. Why don't I do Pythagoras? So it's going to be 4 squared is 16 minus 3.76 squared equals, and take the square root of that answer, and I get 1.36 for this missing side here, 1.36. Okay? Let's go to this figure. Find the missing sides and angles. If the top angle is 30, aha, this will be a 30, 60, 90. So if this is 30, this has to be 60. If this is 56, remember the opposite side of a 30 is always half. To get the ratio, the sine is always half. So if this is 56, that's 28. Okay? And if that's 28, to get the longer leg, it's times root 3. So this would be 28 root 3, which is, this longer side should be 48.5. Now, just to check my work, okay? I said that I think this is 48.5. If this is 30, let's find this side using trig. If this is 30, that's the adjacent side and the hypotenuse. Is that not cosine? So I've got cosine of 30 degrees is the adjacent side, x, over the hypotenuse, 56. Cross multiply. Find the cosine of 30 and take that times 56. And I get 48.50. Okay? Exactly the same thing. Okay? All right, so how about this one? Calculate the direct distance to the airplane and then find a horizontal distance to the airplane with an angle of elevation of 23 degrees. Now, let's talk about this whole concept of angle of elevation. If you are an observer down here, okay, looking straight across, your line of sight is straight across. Your line of sight is that red line. Then you hear an airplane and you look up and you see the airplane, okay? Here's the path through which your eyes, your line of sight, your vision went from here to here. That's precisely how we defined an angle. That's 23 degrees, okay? So I know my angle of elevation is 23 degrees, and I want to find first the direct distance. So I have a 23 here. I have this side is 2,500 meters. And this hypotenuse, this is opposite and hypotenuse, opposite and hypotenuse. So I want to set up sine of 23 degrees is the opposite side, 2,500 over the missing side, the direct distance. Okay, so the sine of 23 equals, I have that on my calculator. Now the problem is when you cross multiply, okay, when you cross multiply, you don't get your answer like the last two problems we did. So I'm going to copy this down. It's 0.3907 is 2500 over x. When you cross multiply, you get 0.3907, and x is 2500. Are you with me? Then solving equations, you've got to take 2500 and divide by 0.3907. Yeah? And I get like 6,399 meters direct distance from you to the airplane. Okay? Now let's find the horizontal distance. The horizontal distance is here, so with the 23 degrees, I have the opposite side, pardon me, and the adjacent side, and that is a tangent. Opposite side and adjacent, so set up tangent of 23 degrees is the opposite side over the adjacent. And once again, it's the same thing. When you go to cross multiply, you're not going to get the answer directly. You got to end up dividing. So I'm going to just do a shortcut of that. Shortcut, I'm going to take the division right away. 2,500 divided by the tangent of 23. Okay? And I get that the direct distance is 5,889.6 meters. There's the horizontal distance right away. Okay? All right. So, I think I have one more problem here for you. Yeah. All right, in the picture showing the angle of depression is 40. Okay, so someone, a park ranger, is up here looking straight across. He sees the other ranger down there and looks down. This is a 40-degree angle of depression, okay? Now, maybe you remember back to geometry in junior high where you had parallel lines. Do you remember alternate interior angles? So if that's 40, then that guy down there is 40. We want to calculate the horizontal distance to the tower. This is 40. Opposite side, adjacent, that's tangent. Tangent, opposite, and adjacent. So I have the tangent of 40 degrees, that angle down there in the corner, same as that one, is 45 over x. And do you see, once again, if you go to cross multiply here, you don't get the answer right away. You end up having to divide. So I'm going to shortcut that. I'm going to take 45 divided by the tangent of 40. Yes? And I get the horizontal distance is 53.63 feet. Okay? 53.63 feet. Trig is a lot of fun. Okay? You can do all kinds of interesting things with trig. Okay? I want to take a couple of minutes and just explain to you something that I did with trig some time ago, back when I first started teaching. This was back during, heaven's sakes, in the 70s. We were having an energy crisis. My wife and I were very concerned about building an efficient home so that we could afford our heating bills and whatnot. We communicated with an architect in Massachusetts named Malcolm Wells, okay? And we then decided to build an underground home. We found a plot of ground that faced the south, and what we wanted to do was insert our house in the hill so that our house would be totally underground. Dirt on the roof, dirt all around the sides, only the front would be sticking out. It would keep us very cool in the summer, very warm in the winter, all right? As we planned our house, I realized that we would have to be very careful because we were going to heat with solar heat. That if we put a lot of glass here on the front, in the summertime, it would literally bake us because the sun still would come in here in the summer. Okay, so I knew I was going to have to put a projection of our roof out like this. I just was not sure how long to make it, okay? All right, so I needed to calculate if I know the angle of sun, the angle of elevation of the sun on the summer solstice, I need to be able to figure out how long to make this to keep the sun out of our house in the summertime. There's a picture of the house, the way it was built back in the late 70s. Here, this white line is that projection I'm talking about to keep the sun out. You can see this was the fall. There's no leaves on the trees here. And the sun is already starting to go into the house. And in the winter, when the sun is lower in the sky, we got huge amount of sun in the house, and it heated our house. But for the summer, I wanted to keep it out. Here is, right here, is the formula that would help us in doing the work here. Our latitude, the latitude of where we are right now, I think was right around 42 degrees. I'm thinking that's pretty close to what it was. It was 42 degrees. So for the summer solstice, you have to take 42 minus 23.5. For the winter, when the sun is much lower in the sky, you take 42 degrees plus 23.5. Okay, but in the summer, it's 42 minus 23.5. So let's do that. 42 minus 23.5, and I get about 18.5. So 90 minus 18.5 is like 71.5 degrees. What that means, the angle of elevation of the sun in the summertime, this is 71.5 degrees. So alternate interiors again, this angle here is 71.5 degrees, okay? And I knew the height of our house here was going to be 8 feet. So what trig function uses opposite and adjacent? It's tangent. So I have tangent of 71.5 degrees is 8 over x, okay? When you multiply, do you get the answer? No, you don't. You have to divide. So I'm going to take 8 divided by the tangent of 71.5. And I get about 2.7 feet. So we did that calculation when we were working with the people that were going to make the concrete planks that would form the roof of our house. And because that was at the summer solstice in June, I didn't want the sun coming in August either. We made it to a straight 3 feet to make it just a little bit longer. And that kept our house in the shade all summer. Okay, just to give you a picture as to what living in an underground house is like, last summer, which would have been the summer of 2019 as I'm filming this, the summer of 2019, our air conditioning in the house only turned on twice, 2 times, the entire summer, okay? It was later on in August when there was starting to get some sun coming in. But it only turned on 2 times in the entire hot, humid summer of 2019. It's an amazing house. Winter, with all this glass, I would leave to go teach in the morning, and when I come home in the afternoon, I oftentimes would see in the winter, my wife would have windows open because the house got so warm, she would be opening windows from all of that sunshine. Later on, we decided to change the design of the house a little bit. We still wanted to use the sun, but we wanted to change the design. And in the year 2000, we remodeled the house. It looks like that. You say, well, that's just a normal house. No, it's not. Look how thin this is. This is only about 8 feet right here. This is the projection we put on the front of the house. The rest of the house is still back there. You can kind of see the green there. That's what I have to mow in the summertime because I have to mow my roof. Okay, so the house, the vast majority of the house is still under the ground. But what about the sun? Ah, yes. And what about the sun? So now we have solar panels that gives us all of our electricity. We are totally carbon neutral. In fact, last year, 2019, we produced more electricity than what we used. We also have an electric car that we get our fuel from the sun. So it's just a beautiful, wonderful, remarkable way to live. Homework. There's one review problem and a variety of problems dealing with trigonometry.